Hello, everybody. So in this video, we will look at how to draw Lewis structures of some sulfur and oxygen containing compounds. So let's start with um, say SO3 2 minus. So SO3 2 minus. First, we're going to start counting the number of valence electrons. Sulfur has 6 valence electrons and oxygen has 6. We have 3 of them. 3 times 6 is 18. And then we have a -2 charge that's going to give us 2 more electrons. And altogether, we have 26 electrons, meaning 13 electron pairs. And then we draw the skeleton of these of this molecule. Then we are going to draw the sulfur in the middle. Even though sulfur and oxygen have the same bonding capacity, sulfur is larger, therefore sulfur goes to the center. And then we have 3 oxygens bound to it via covalent bonds. Okay, and then what we're going to do is we're going to distribute the remaining 10 electron pairs. We have used 1, 2, 3 electron pairs in the 3 bonds, and then we're going to distribute the rest of the electron pairs starting with the outer atoms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the 13th must go on the sulfur atom like that. And now we see that around oxygen, we have 3 lone pairs and 1 bonding electron pair, 8 total electrons and octet on oxygen. And on the sulfur, we have 1 lone pair and 3 bonding electron pairs, meaning 8 electrons around sulfur as well. We have octets around all the atoms. Therefore, this is going to be our Lewis structure for SO3 2 minus. We're going to draw a square bracket and indicate the charge at the top right corner like this. Right, that is SO3 2 minus. Now let's do another one. This time let's do SO3. SO3 is a molecule as well. No charge. Sulfur again has 6 electrons, and then oxygen 3 is 6, but we have 3 of them. Therefore 18. Altogether we have 24 valence electrons, meaning 12 electron pairs. And again, we need to draw the skeleton of the molecule. So we're going to draw sulfur in the middle because it is larger, even though sulfur and oxygen have the same bonding capacity. And then we going to draw the skeleton, which is oxygen is bound to sulfur like this. And then we're going to distribute the rest of the electron pairs, starting with the oxygen atoms, so outer atoms. So we have 1, 2, 3 here, and then here's 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now we see that we have 8 electrons around our oxygen atom. So we have an octet around oxygens because we have 3 lone pairs and 1 bonding electron pair. Altogether 4 pairs means 8 electrons, 1 octet of electrons. But around sulfur, we only have 3 bonding electron pairs, meaning only 6 electrons. And therefore, to get an octet around sulfur as well, we are going to delocalize one of these lone pairs from oxygen. So we can delocalize from the top one, or this one, or from this one. So we have 3 options, 1, 2, 3 options. So that means, we're going to end up with 3 possible Lewis structures, or we call resonance structures. So let's draw the resonance structures of this molecule now. So if one happens, then the possible structure would be have a double bond with the top oxygen, and then we have the other oxygens bound by a single bond to the sulfur atom, like this. And then if the second thing happened, then we are going to get the double bond on the left-hand side oxygen and sulfur, and then we're going to end up with this structure. Okay, and if the third one happens, then we are going to get the double bond on the right hand side like this. Okay, and then the other ones are just single bonded oxygen atoms. It's going to look like this. Okay, so these are called the resonance structures because we just drew them. These are three possible structures for the same Lewis, same molecule, drawn by rearranging the electrons. So these are called resonance structures. Resonance structures. And then just remind ourselves about the experimental structure. Is a hybrid of all of these resonance structures. So in the experimental structure or the hybrid structure, what we're going to have is we have sulfur, but each bond is between a single and a double bond, right? So here we see that we have a double bond between the top oxygen and the sulfur, and in the other ones we have a single bond between the top oxygen and the sulfur. That means this bond is in between single and double bond. So we're going to indicate that like this. And the same goes with the other two oxygens as well. So this is going to be our hybrid structure. So let's write that this is our hybrid structure. Okay, so that's it. So the idea is, I know that there are some structures on internet for SO3 2- with sulfur having more than 8 electrons around it. The idea is, yes, sulfur can violate the octet rule, but we are not going to violate any rules unless we really have to. So we can draw a structure without violating the octet rule. Yeah, that's why we have SO3 2- have only one structure without resonance, which looks like that. When it comes to SO3, we need to delocalize electrons to get an octet of electrons around the sulfur atom, and that's why we had to do this. As a result of that, we are going to get 3 resonance structures, and the actual structure will be a hybrid of all 3 of them, which is drawn over here. And notice that we do not draw lone pairs when we draw the hybrid structure. All right, that's it. I hope this helps. I'll see you guys in class. Bye, everybody.